Hello everyone, welcome to my your programming club. Today we will be solving another daily lead code problem, and the problem's name is integer to English words. Okay, and the problem statement goes like this. So you have to convert a non-negative integer nums to its English word representation. Okay, so for example, if you take the third example, then in this third example, you can see that we are processing the number that we are given into ranges of 3 or batches of 3. Okay, so if we are processing the number in batches of 3, then what is the maximum number that can there be? We can have a look at it by observing the constraints. So it is 2 raised to power 31 minus 1, so it will be in billions. Okay, 2 billion something. So the highest number that can there be is in billions. Okay, so you are clear with the ranges of the numbers that we will be dealing with. Okay, and from this particular example we were able to observe that the number is being processed in batches of 3. Okay, so you can see that 1 million is a separate batch and these 3 are different batch. So if you want to take to the board, we can do that and have a discussion about it. A brief discussion will be fine, just to give an idea how things are going here. So here you can see that this particular number is processed like this. Okay, so it is for hundreds. Okay, 567, and this one is for thousands. This one is for millions, and after millions it will be billion. Okay, so in batches of 3 we are doing it. So it will be wise to break down this number into batches of 3. Okay, the first observation solve this particular problem is process this number in batches of 3. But this is only a small part of implementation that we will be doing. The next question that might come into your mind is how we will be mapping these numbers with their respective words. Okay, so we need to know that how mapping of numbers, or you can say digits, will be done to their respective words. Okay, so for that we will be using string arrays. Okay, and I will tell you in the implementation part how we will be using that, but the concept I can tell you is will be that you will be having a string array, and the indices in this string array will be representing the digits. Okay, so these will be the digits, or you can say numbers, and these will be their corresponding respective word values. Okay, so corresponding word values. For example, for 0 it will be 0, for 1 it will be 1, for 2 it will be 2, and you will keep doing it in the same in a similar fashion. This particular string array I have given example of ones place, and similarly there will be 3 arrays here, and we will see those arrays in a little bit of time. And this is the logic how mapping will be done. Okay, mapping will be done with the help of indices of string arrays. Okay, now let's bring the implementation to the board, and it will reduce us some time of explaining the concept, and you will be able to understand in a better way. Otherwise I have to write down the entire arrays to make you understand how things are working out. Okay, so and the two things that will be taken care of, the one thing is that processing the number in batches of 3. The other thing is that mapping should be done, and that mapping will be to the uh, integer to their respective words, and this will be achieved with the help of array of strings. Okay, so indices in those arrays will represent the numbers or the digits, and their values will represent the corresponding equivalent words to those numbers or digits, you can say. Okay, so let's take the code to the board, and let's take a fresh slide for that. So this is the code. I know it's a little bit lengthy, but be with me, and you will be able to understand what how we have implemented and what we are doing here. So now I think it's scrollable, so we should be removing this toolbar also, and let's break down it even further so that it's manageable. I think there should be not any overlap right now. So yeah, let's discuss what's happening in the code. Okay, so as I already told you, we the very first observation from those examples was that you have to do processing in batches of 3. Okay, so for that we have made a function process batch, and it will do the processing of the number into uh, batches of 3. Okay, and each time you will take the last 3 numbers and give it to the uh, this function for processing, and it will return you the corresponding string for it. Okay, so what you will be doing is you will see, I was saying that we have to do processing in the batches of 3. So if you take modulo with respect to 1000, then it will give you the last 3 digits. For example, if the number is 573, or let's say it's 1573, then if you take modulo of it with 1000, then the last 3 digits will be given to you, which will be 573. So that's the logic. So for making the current batch, you will be using this logic. Okay, this will be your current batch. Okay, and the nature of this modulo operator is that it will give you the batch from the end. Okay, so that's why we are doing the processing from that side. Okay, and then once you are done with this part, then you would be wanting to get rid of this part. For that, what you will be doing is you will be dividing this number by 1000. Okay, and you will take the quotient. Okay, so it will be 1. So that is why the rest of the part is removed by this operation. So this is what we are doing here. Okay, removing the processed batch. Okay, and then for each batch we are having an index. I will tell you in a while why we are using this batch index. Okay, and we will dive deep into the implementation of this process batch function now. Okay, and as I already told you, if the number is something like this, okay, and you are doing the processing from this direction. Let me change the color here. If you are doing the processing in this direction, so you would be wanting that whenever you process a new batch, its result should be appended to uh, the front of the existing result. Okay, so if you are processing 234, then its result should be appended in the front of this, the result of this. Okay, let's say the result of 556 was y, and result of 234 was x, so it should be xy. Okay, not yx. So that's why we are appending the result of each batch to the front of the final result that we have to return. Okay, so this is our final result answer. Okay, so now let's dive deep into the core logic of this particular problem, which is how mapping will be done and how words will be formed. Okay, so some part of it I have already told you, that we will be using these string arrays, and the indices in this string array, these string arrays will be the numbers, and their values in these string arrays will be their corresponding words. Okay, so for example, here 0 was empty, 1 was 1, 2 was 2, 3 was 3, and so on it will continue. Okay, so it will continue till 19. So 19's corresponding word is 19 in a string form, you can say. Okay, so this is how mapping is achieved here. Okay, and then we have taken kinds of arrays, three kinds of arrays for different kinds of places. So ones place, then tens place, and then thousands and beyond. For thousands and beyond, first of all, you will be, as in we happen in the number system, there will be thousands, then there will be millions, and then there will be billions. Okay, so let's see how the processing is done. So first of all, you will be needing some string or something to hold your current batch result. So you will be using this string builder here, as we have done implementation in Java. So it's a little bit efficient to do it rather than using normal strings. Okay, so then here you are processing the hundreds batch. Okay, for processing the hundreds batch, you would be wanting to gain the index which you would be looking in the array. Okay, and since you are processing the hundreds batch, so you would be wanting that to look for the thing that you want to look in the array of ones. Okay, so for example, this 567 is given to you. So this 500, you can see the break this into words 5 and then it's 100. So 100 is always appended irrespective of whatever this number is, and this is only one's single digit, so you will be looking that up in the ones array. So for gaining the index that you should be looking up in the ones array, you will be dividing it with 100. Okay, so if 567 is divided by 100, it will give us 5. Okay, so that is why we are using this logic. And once you are having that index, then you will first of all gain access of this string 5 and then append 100 with it. Okay, that is what we have essentially done here. And now the second last two digits of the number will be processed. For that, you will be wanting to reduce the number to 67 only. Okay, so in order to achieve that, you will be wanting to remove this 5. Okay, to remove this 5, we are taking modulo with 100. So if you take modulo of 567 with 100, it will be 67 only. So in order to separate last two digits, we are doing that. Then we are doing the processing of the tens digits. Okay, And for the tens digits, we have starting with 20. Okay, if your number is greater than 20, then you will look up into the tens arrays. Okay, and you might ask, what are these empty strings? Okay, so I will tell you that these empty strings are for the strings which are not having any mappings right now. So in tens, 0 will not be there, and 10 will also not be there, because we have taken tens into ones array. Okay, so then the corresponding entry will be 20, so we are starting with 20. Okay, so that's why two empty spaces. And here also you can see that all the entries, all the arrays are having at least one empty space, indicating that we are not taking mapping of 0, because if the number is 0, then you can directly return it from simple check only that the number is 0, so you will be returning 0. That's why these empty strings in the array. Okay, so if the number is greater than 20, then you will be applying the pretty much the same logic that we have applied for the hundreds batch, and you would be gaining the access of the index that you have to look up in the tens array. And once you have done that, then you will go to the tens array and fetch that corresponding word. Okay, and you will take care of the spaces in between. I hope space part you can manage to understand by yourself. Okay, then uh, you will be wanting to extract the last digit, this 7 digit. So for that, again you have to take a modulo operation, and this time it will be modulo 10. So 67 modulo 10 will be 7, so 7 will be extracted out. So that's why this logic. Okay, and now you will be having access to a single digit only, and if that digit happens to be greater than 0, then it's fine, and we will be processing that digit. Similar to the above approaches, we will be wanting to have index that we should be looking up in this ones array. Okay, and now once we are having access of that, you will simply append it to the current batch answer. Okay, and now the interesting part comes in for adding the uh, first digit, or first word. Okay, which will be either thousands or billions or millions. Okay, so for that, what you have done here is this batch index will be helping you out here. Okay, so since when you will be processing the hundreds, you will be not requiring anything. Okay, that's why this empty string. Now if you are going beyond hundreds, let's say 567, after 567 there is something 123, then this will have a thousand with it, thousand word attached to it. So initial its batch index of this one was 0. Okay, and this one will be of batch index 1, so that's why thousands will be appended. Okay, so that is the logic of using that batch index and incrementing it after processing each of the batch that we have processed. Okay, and since the numbers can go up to billions, so we have taken billion as the last entry in the thousands and beyond array. Okay, so in this fashion you will keep building your batches corresponding numbers or words, and then you will be appending it to the final answer, and appending it to the final answer in the front of it. Okay, so in order to get the correct output, and then since we have to take care of some trailing spaces or some spaces before the word, then we have used this uh, trim function, which will trim the trailing spaces and the spaces in the front. Okay, although it will only be having spaces in the end, but uh, this trim function will do the job. and it will return you your expected answer. Okay, so the very core logics of this problem was to first of all understand how you will be processing the given uh, integer for making it to the words. So the first observation was that you will be doing the processing in batches of 3, and the second observation was that you need to find a way to map the integers with their corresponding words. So for that we have used these string arrays in which the indices represent the numbers, and their values of the string arrays at those indices represent their corresponding words. Okay, so and then for doing some extracting the exact things that we want to map to their corresponding word values, we have used this modulo operator and this division operator. Okay, so I hope everything is clear to you, and this is the implementation and approach part. If you are still having any kind of doubts or any queries in general, then you may ask them in the comment section, and I really hope this solution walkthrough added some value to your journey of honing your DSA skills. Until next time, keep solving more and more problems, and I will see you in the next video. Thank you for watching.